Part 3 of Lesson 4, Chapter 2 is going to be using synthetic division to find additional zeros. If you look at this problem, it gives us a fifth-degree polynomial, and it's got three different parts to it, A, B, and C. We're going to start with Part C first. It says list all the zeros. Well, you can see off to the side over here, I'm given three of the zeros. So we know three of them. We got to come up with the other two. So to do that, I'm going to use synthetic division. I'm going to use synthetic division with a -5, and I should get a 0 at the end. Notice that I've got a missing x to the fourth term, so I need to include a 0 in my synthetic division. And as I mentioned, I should get a 0 at the end of this because it tells us that -5 is a 0. Sure enough, we get a 0 at the end. And now I'm going to use the next given 0, which in this case is a 2, and I'm going to do it with the resulting coefficients, and again I should get a 0 at the end. Okay, we get another 0. I'm going to proceed by using the third 0 given, which we've used the -5, we've used the 2, now we're going to use the 3, along with the resulting coefficients, and again we should get a 0 at the end. So everything's working out like we thought it would. And so now I take these resulting coefficients, and that leaves us with x squared plus 0x plus 1. We set that equal to 0, and now, x squared plus 1 equals 0, x squared equals -1, and we get plus or minus I, because the square root of -1 is equal to I. So I just found my two additional zeros, and let me list those. We had -5, we had 2, and we had 3, and then plus or minus I. There's the 5 zeros for this fifth-degree polynomial. Now we're going to go to Part A. Part A says write this function as a product of linear and irreducible quadratic factors. So since it has an x-intercept at -5, I write x plus 5. I'm also going to need an x minus 2 and an x minus 3. And then I'm going to use my resulting coefficients down here to write an irreducible quadratic factor of x squared plus 1. So there's the function written as a product of linear and irreducible quadratic factors. This right here is the irreducible quadratic factor. Because it cannot be factored, we leave it like that. Now Part B is really similar. It says write it as a product of just linear factors. So I'm still going to have the x plus 5, still got to have the x minus 2, and I still got to have the x minus 3. But now I'm going to take that irreducible quadratic factor, and I'm going to write it as x minus I and x plus I, which are written as linear factors. Let's do one more problem, same type. This is example 7. We're given a fourth-degree polynomial this time. We're going to tackle Part C first, which is to find the zeros. You can see that I'm given two of the zeros right here. So I'm going to use those zeros with synthetic division. I'm going to start with the 5. It doesn't look like I'm missing any coefficients. And so I should get a 0 at the end of this. Something didn't work out there. Let's try that again. What did I do wrong there? All right, so we're going to use a +5. We got a 1, -26, a 4, and a -120. All right, let's try this again. Should get a 0 at the end. There we go. Okay, get a 0 at the end. Now I'm going to use the next 0 of negative 6 with those resulting coefficients, and again I should get a 0 at the end. Alright, now I can take these resulting coefficients, and I can take x squared plus 4, set it equal to 0 and solve, and that's going to give me x equals plus or minus 2i. So, part C, listing all the zeros, we've got x equals 5, we've got x equals negative 6, and we've got x equals plus or minus 2i. Those are my 4 zeros. So then as we go to part A, to write this function, we need to have an x minus 5, we need to have an x plus 6, and then we'll need to have an x squared plus 4. That's the irreducible quadratic factor that was given at the end right here from using the synthetic division. And then part B, writing this as a product of linear factors, we'll still have the x minus 5 and the x plus 6, but now we'll have to have x minus 2i and x plus 2i. So that is the third day of lesson 2.4 on zeros of polynomials.